Hello guys and welcome back to another episode of the BeamNG Monitor tutorial series, and in this episode we're going to have a look at ABS, stability control and traction control. For that I made a new file with some parts. First there is the DSE, which I show you already, the driving safety electronics part, which is a slot in the body, and in there it just has two more slots for ABS and stability control and traction control, which is handled together. And you can see that's this part right here, and we have the ABS down here. Obviously for now it's empty. Yeah, I didn't bother to show you the process of making these parts because yeah, you already know it. And yeah, the ABS is actually quite simple. We just go pressure wheels, pressure wheels section. There you go. I still had it in a clipboard, so yeah, just copied it. And now the only thing I have to do is enable ABS. Set to true. And yeah, that's it. Except that you might go into your brakes part, and in here define a ABS slip ratio target, which basically tells the ABS system what kind of what amount of slip to aim for when controlling the braking. This value differs from some cars to others, and if your ABS is still locking your tires too much and not really allowing full control, you should lower this value. If you think your vehicle isn't braking as well as it could under ABS, then you can increase this value, so you land in some kind of sweet spot where you still remain the control of the vehicle, which is the use of ABS, but still get maximum braking performance. Alright, that's already it. By the way, I called the new file DSE for driver safety electronics, but yeah. So let's go ahead and take off, brake, and there you go. You can see we have ABS. I think that works exactly as it should. Yeah, as I said, ABS is simpler than stability control and traction control, which is what we're getting to now. If we put in the standard, you see traction control, you can see it's already working. And that you can see it right here. First of all, the ESC is controlled by a new controller just called ESC, and then we changed the parameters for that controller right in here. First of all, the all the wheels that will be affected by stability control are those, which is standard, as you could change them depending on what wheels, what amount of wheels you have and how they're called. Then is debug mode just 0. We don't really want to debug. The default config is which of these three configs, in my case, should be used as the default one. And yeah, then we have these different configurations here. First one is regular ESC, and then we have a few values for ESC and then one for traction control. So let's start at the top. ESC enabled, pretty simple. It's just a true, and then configuration enabled, also true. And then order defines in what order you cycle through them. And then we have the active color, which in this case, this color code represents some sort of bright green. And now we get into the well, a lot more difficult measurements or parameters. Yeah, right, parameters. First, we have the maximum side acceleration, which basically says how much side acceleration your car can can have at a maximum. I mean, you can measure that with the G-force meter. So that's about 1 G. I can't get it any higher than that. Yep, 1 seems to be around the minimum, the maximum. So 1 G is 9.81 meters per second squared. So yeah, could put that in, but 10 is alright too. Then brake force multiplier is just 1, and I mean I could put it up to 2, and the stability control will use twice as much brake. Then we have ESC threshold, which is the threshold at which the ESC starts to act. Lower values means lower amount of slip, or in the case of this ESC system, it's calculated using yaw rate. So the difference between what yaw rate you would have when taking a normal corner and the one you're having at the moment. So if we are just taking this corner like usual, we don't have a difference in what we would expect as a yaw rate and what we're actually getting, and then the stability control won't act. But if you start skidding or sliding, then the yaw rate will be higher than what we would expect from the car. And yeah, by the way, yaw rate, if you don't know, is just how fast the vehicle turns around the z-axis. So how quickly it's turning around. Then the characteristic speed. I had a lot of fun googling that. In this case, when you set it to -1, means it's getting automatically calculated. But the characteristic speed it's got to do with understeer. So yeah, characteristic speed is the speed at which you need twice the steering input to maintain this on an understeer car, where you need to put in twice the steering angle of what you would need if the car was had a neutral setup, so it was perfectly following the tires. And it's an important measure that the ESC somehow uses to calculate things. Yeah, but if you put a -1 there, it's getting automatically calculated, and there's not really much need to worry about that. Oh, more than that. Then there are two factors for proportional and integral. First, the proportional one. Yeah, that changes how much of an effect, immediate effect, the stability control has. So depending on the yaw rate right now, the difference in yaw rate right now, it changes that value. And then the integral factor changes how much over time gets added onto the brake input. So for example, if we keep turning or keep sliding to the left, the integral factor, or the integral, will continuously add more and more and more brake pressure to well, front right brake in that case. If we slide to the left, it will activate the front right brake. And yeah, the integral pad will just keep on increasing and increasing to, yeah, try to further counteract that. Because yeah, if it doesn't get back fast enough, it might not, the car might not be reacting as quick as you want, so the stability control will add up, yeah, brake pressure over time while it's active. For that reason, I wouldn't change it a lot. I mean, these values are fine like they are. So just that you know. Then we get to something that I don't really understand a lot myself, but this is called the skew stiffness, both for front and rear. This changes how the the characteristic speed is calculated, because we put a -1 at characteristic speed. Means now the game has to calculate the characteristic speed itself. And this skew stiffness changes how it's done. And if I think I'm correct to believe that the higher the front is in correlation to the rear, the earlier the game will calculate the characteristic speed. But I'm not too sure on that. Yeah, I looked at, let me show you that. This is the ESC controller. And if we just go ahead, search for skew stiffness. Oh, it's already here. You can see it calculates the characteristic speed through some sort of calculation with this EG value, which is calculated using the skew stiffness. Having a higher skew stiffness rear. Wait, if we have this as a higher value, means this total value is higher. And if we then divide by something, then it will be again higher. That's also okay. The higher the rear stiffness in comparison to the front stiffness, the lower the characteristic speed. Which I believe actually makes sense, because the softer the front and the harder the rear, the earlier you get understeer. If that somehow makes sense. Yeah, but I personally would just go into some other yeah, vehicles that are similar to yours and look at the ESC and just copy the values from there. For example, I believe, wait, from which car are these? I don't know. I copied them from somewhere. And then we have desired yaw rate smoothing, so just how smooth the ECU, I'm always mixing up those words. The ESC will try to bring your car back on course. And 550 is alright. Wouldn't change that much, really. Then we have the TCS, so traction control now. And here we also have a slip threshold similar to the ABS. And that is just what the traction control will try to aim for under acceleration, how much slip you want. Then we have a minimal throttle factor, so the traction control will use both throttle and braking to control the slip. And there we have a minimum throttle factor, so no matter how much it wants, the traction control cannot reduce your throttle below 20% or 0.2 in this case, and it can increase the braking, brake torque applied to a wheel above 60%. Then we have the same values here. We have a throttle proportional factor and a throttle integral factor. which it does exactly the same as up here. So the integral factor, just the regular factor for a calculation happening right now, based on all the measurements that are happening right now, and then the integral is something that again adds up a lot. And then we have the brake throttle switch threshold, and yeah, it's just said at which speed do we change. I mean, it could show you if we launch it now. You can see it uses the brakes, the rear brakes in this case, to stop the wheels from spinning, but at higher speeds it will reduce throttle, which is, I think, because the brakes are more responsive. So yeah, but after some speed, which in this case 40, it will then change them. Here you can see the sport ESC, which is pretty similar. In this case, we assume that we can reach higher maximum side acceleration, and we have also a higher ESC threshold, so it will activate later. And yeah, and also we allow a lot more slip to happen, and we don't allow it to regulate that much. And then in the last case, ESC off just turns on the just puts the ESC enable to false, and then override ESC pulse, which is this down here. You can see it pulsing right there. It just means that it just stays like that off. Yeah, I can show you the difference between regular and sport traction control. See, sport traction control actually already allows a bunch of slip there. But yeah. Also, I do have to mention that there is a newer system BeamNG uses, but that's actually very complicated. It's used in actually quite a lot of cars now. The Scintilla uses it. Uses it. The SBR4 also, which is now new, and yeah. But I believe this old system, well I mean, old, it's just been kind of replaced in the newer cars. I think this system also works fine. If you do want to cause yourself a bunch of headaches, you can go to some lengths to make the new system work, but I'll just stick to this one. And yeah, thank you guys for watching. Like if you liked, and dislike if you didn't. Hope you guys learned something new, and I'll see you guys again in the next episode.